Okay, so we have the graph crossing the x-axis, and you can see the discriminant going from negative to 0 to positive. So what does this number tell us? Okay, so when it's positive, what do you notice about the graph and where the two intersect, the straight line and the parabola? And when it becomes 0, what do you notice? Okay. And when it becomes negative, what do you notice? Okay. What does this number tell us? Okay. Any ideas there? Anybody know how to put that into words? You can see it, but how would you explain that? So when it's positive, it's right here. When it's negative, it's right here. I mean, when it's 0, it's right here. And when it's negative, it's up here. So what is this discriminant number telling us? Okay. Anybody got a way to say this? Explain it? Pretty straightforward. If it's positive, how many solutions are there? How many x-intercepts are there? Like right now. There's 1, 2. So positive discriminant, you have 2 answers, right? What happens when this becomes, this one. What happens when the discriminant becomes 0? How many answers are there? Right? Yeah, there's 1 right there, just the vertex. The vertex is right on the x-axis. So when you have a discriminant of 0, right, you see you have a 1 solution. The vertex is the solution. And as soon as the discriminant becomes negative, how many answers are there now? How many times does it cross the x-axis? Okay. 0. It doesn't cross it at all. Okay. So this discriminant tells you how many answers there are. Without having to try to graph the whole thing to see where it crosses, this discriminant tells you ahead of time. It also can tell you that, well, maybe you have a negative discriminant like right now, that you won't be able to factor this. Because remember, factoring gives you the x-intercepts, right? But if there are no x-intercepts, it will be prime. It will not be able to factor. But the nice thing is that we also had prime polynomials that we couldn't factor, but they did have 2 solutions. They're just decimals. And that was the thing. Prime could mean there's no answers, or it could also mean the answers are decimals. So we can't just say prime means no solution. It could mean decimals, and this will tell you, now the discriminant is positive, we do have 2 answers. Even though it's prime, I can still get 2 answers here. Okay, they're just some sort of decimals or fractions. Okay, so that's the big picture for the discriminant, is it tells you how many solutions there are, not what they are, but how many there are from the very beginning, which is kind of going to be important here. So big idea here, picking up where we left off, is that we really don't care too much that the answer is 64. Not a big deal. It's if the answer is negative, 0, or positive is what's important, right? So the 64 doesn't mean a whole lot. It's the fact that it's positive 64. Okay, that's what's important. Okay. Same thing down here. The negative 20. The 20 doesn't really mean anything. It's the fact that it's negative. That's what we're looking at, and that's what the answer is. Okay. And down here, when you have a 0, that's what's important. So without graphing it, I can tell, just by calculating the discriminant, negative means how many solutions are there. Okay. So going back, okay, negative. How many times does this cross the x-axis with the orange line? None, 0. Negative discriminant means there are no solutions, no x-intercepts, no answers. Okay? So on all these, you can say anything that has a negative, you can go through and say 0 solutions. So go ahead and do that right now. Any of those answers that have a negative, right? We want to write 0 solutions. And if you look at the directions, that's really what they're asking. They're asking for, carefully right here, state the number of solutions, right? That's what we're trying to get at. The number, not too important. The sign of the number, that's where your answer is. Okay? Now, same thing down here with 49. doesn't really matter it's 49. The fact that it's positive means there's how many solutions? Okay, 2 solutions. So anything that's a positive, go ahead and write 2 solutions. 2 solutions. And lastly, like number 9 equals 0. Since it's equal to 0, right, we know that's going to be 1 solution. And with 1 solution, it also means it's the same as the vertex. The solution is the vertex. So when you're getting ready to graph and calculate these, if you do the discriminant, just find out what b squared minus 4ac is, and you find out, oh, that equals 0. Well, you don't really have to find the x-intercepts, then find the vertex, and then find, all this stuff, because the x-intercept and the vertex are the same thing. So this will give you a little roadmap when you're starting problems of what you should do. Right? If it's not prime, if it's factorable, right? You can factor it. If it's not, you might have to do a t-chart. Okay? So something like when you have 2 solutions, you can go ahead and factor it and say, oh yeah, that's going to be 7x times x minus 1. Yep. And we can get the 2 x-intercepts that way. When you're doing this, where the vertex is also the solution because the discriminant equals 0, you can just go ahead and find, well, if I find negative b over 2a, that's going to be the vertex, but it's also going to be the x-intercept. They're the same thing when the discriminant is 0. And when you have a discriminant that's negative, there are no x-intercepts, so you're not going to bother factoring it at all because it doesn't factor. It's going to be prime, right? So you can just go ahead and make a t-chart and start graphing it that way. So the discriminant kind of gives you a little guidelines on, well, now I'm going to throw everything together, all different types of polynomials. Well, how do I know without doing trial and error where I should start? And that's the big idea there. All right, so you've gone through. Make sure you actually wrote this. This is the answer we're looking for. Okay, 1 solution, 2 solutions, 0 solutions. Just be careful here because there's sometimes a mistake that people would like to say that 0, when you get an answer is 0, they sometimes say 0 solutions. That's not the case. A negative means 0 solutions, and a 0 discriminant means 1 solution. So try to keep that straight now and not mix it up because it's really easy to connect a 0 discriminant with 0 solutions, which will mess everything up. Okay, so use this as a guide to help us graph, and we're going to play with that a little bit more. All right. Okay, let's go back to Desmos and let's add a folder. Let's call that Quadratics. Quadratics. Okay, just gonna put all these in here. Need that one later. And take a look at the graphs you see in front of you, the first ones. They're not quadratics. What were those called? Those bars when they have bars on either side.
Oh,
absolute value. So we're going to do a little revisiting some absolute value right now. Okay. Oops. Absolute value. There we go. X plus h plus k. Okay, there we go. That one. And let's do a little reminder about this format and how do you graph them. Let's see here again. Let's make these go by. -6 to 6. Let's count by ones. 6 to 6. Count by ones. Okay. All right. So if I move the number on the inside, okay, what does that do to the graph? All right, so let's put that in motion. Let's take off the y-intercept. There we go. So how does the number on the inside move the graph? Horizontal, left to right. Now, remember, it's a little bit different from what you remember, that you see how it's negative and it moves it to the positive side. So a -2 in here actually moves it to the right. So that was a little counterintuitive. And if you made the number positive, it moved it to the left. So that was the one thing when we were graphing this you had to remember, that it's a little opposite on the inside. Okay? The number on the outside, kind of like the C value we're dealing with now, but the number on the outside here moves the graph up and down. And that moved according to what we'd expected. Okay? The negative is down and the positive is up. Okay? Now, we have an A also in the front. What does that do to the graph? Okay. That was kind of like a slope. So very similar to parabola. You see how negative is down and positive is up? So there's a lot of similarities here between absolute value and quadratics. The only thing that's really different is that absolute value is this V shape with, a pointed corner. Parabolas is kind of like a smooth curve. But they behave very similar. Okay? So let's just do a little practice real fast on here and just remind ourselves how to graph these. Okay? So let's make some notes. So for like number 1, our vertex, right? Our vertex here is going to be at +1, right? So it's the opposite. Remember, it's the opposite of the number in there. And then comma -4. That one's the same. So we can find the vertex just by looking at it. Think about all the work we did for parabolas to find the vertex, -b/2a, or factoring and then taking half of it, find the middle of it, how long that took. And here we can find the vertex in 2 seconds. Okay, kind of nice. So we can go ahead and graph this. So we got 1, -4, so that's down here. 1, -4. And then we use the A value, right? That acted kind of like a slope. It was like y = mx + b, right? That was like a slope. So it's actually 3/1, so it's up 3, right 1. So from our vertex, we just had to go up 3, right 1, up 3, right 1, up 3, right 1. And much like a parabola also, there is symmetry. So if there's a point on this side, there is another one on the other side. Right? It's also equivalent of going up 3, left 1, but it's also symmetric. So you can get both sides of the graph, or you can get one side of the graph just by having the other side, just like a parabola. And then, of course, use a straight edge of some sort, the side of your phone or calculator, and there's the graph. And much like the discriminant, when we were finding discriminant, if it's missing a number, what should you use? Yeah, see how there's no number on the inside being added, subtracted? So if there's missing a number, use a 0. This one will be at 0, -3. We know the graph starts right here. The vertex is also the y-intercept. And this time the slope is 2/1, so that's up 2, right 1, starting at the vertex. Up 2, right 1. And then use the symmetry down the middle to get the left side. Remember that if it's positive, it opens up, negative opens down. Okay, all these are going to be positive right here, but they could also be negative and you need to go like down 2/1 or something like that. Okay, use a straight edge, get your graph. There we go. Okay, go ahead and do 3 and 4. Get the hang of it. please write it just like this. Vertex, is this. Vertex is this. Explicitly write it out. If you want to, you can also label it on the actual graph. In parentheses. All right, going to do that. Since they have a lot in common, we can just replace that absolute value with a second power to make it a parabola. Just because it has a second power in it, and that's the highest exponent, so I know it's a parabola. Okay? But I can do the same thing. I can say, well, the vertex, and it's going to work the exact same way. Okay? So the vertex here will be, what is it? What's the x? -1, right? It's opposite. And the y is going to be 2. So I know the vertex of this parabola, because it's written in this format, it's at -1, 2. Okay. And is this going to open up or down?
Down.
Which way? It's going to open up or down?
Yeah.
Down, because that's negative. So I already know it opens down. And we can just kind of do a t-chart here and say, well, I got -1 and 2, that's my vertex, right? Let me find out some points around it. Let's go one lower and one above. So I got -2 and 0. That's one below and one above vertex. And I know those two answers are going to be the same because of the symmetry. This is what we're pulling together everything from last week. So let's plug in 0 and see what the answer is so we can graph this a little more. So plug in 0, you'll get, let's see, f of 0, which just means plugging in 0. You got -0 plus 1 squared, and then plus 2. So you got -1 plus 2, which equals 1. We have 0, 1, and we also know we get this one for free. They're going to be the same answer because of symmetry. So I know this will be 0, 1. That's going to be an answer. And then the other side also is an answer. And if we wanted to, we can plug in +1, and we'll get the answer for 1 and -3 as well. But I'm just going to sketch that the way it is. Now remember, this isn't an absolute value anymore. This is a parabola. Since it has a squared, make sure you draw a parabola shape. Try to make it as symmetric as possible. Now, there's one more question on there. Is the discriminant negative, 0, or positive here? So looking at this, just by looking at the graph, how many solutions are there? There's 2, right? Right here, you're looking to see where it crosses the x-axis. So is the discriminant positive, negative, or 0? It's positive, right? It's positive. So discriminant is positive. I don't know what the number is. I don't know if it's positive 16 or positive 500, but I do know because there are 2 solutions here. 2 solutions means positive, okay? Positive, right? So we're kind of doing this. We're starting with, okay, there's 2 solutions. There's 2 solutions, and I'm saying, okay, therefore it's positive. I'm going the other direction we just did. 2 solutions means positive, so right, that looks like, that's not a very good one. Like this, 2 solutions, right, 2 x-intercepts. And remember, we can have 0 solutions that can look like this, doesn't cross at all. And we can have 1 solution that looks like this, right, where the vertex is also the x-intercept. Okay, so those are the 3 possibilities. So on each of these, we're also going to say, well, is the vertex positive, negative, or 0? Okay. So let's see here. Put over. Let's say number 9. Let's try another one. So first write the vertex. The vertex. So what do we get from the vertex on this one? 3, comma, -4. That. 4. Does it open up or down? Up on this one. So again, we know that because it's positive 2, so it opens up. It's the sign once again. And now, let's see here. We can think of a t-chart here, and we know 3, -4 is the middle of the graph, so it's the middle of the chart. And let's plug in the number that's 1 above and 1 below. So let's say 2 and 4. We know those will have the same answer. You can even do a couple of them and say, well, 1 and 5, those will have the same answer. So I'll plug in 1 and I'll plug in 2 and see what the answers are, and that can be correct. So let's plug in 1. And put 1, which means you're plugging in 1. Times. Should be 1. 1 times 3 squared. Minus 4. 2 times 4. Minus 4. 1 minus 3 is -2. -2 times to the second power is positive 4. We get 8 minus 4 equals 4. So we have plug in 1, got an answer of 4. So that's 1 comma 4. I also get the other side for free. 5 comma 4. Same answer. 1 4. 5 4. No. And let's do the 2 as well. That's 2. 2 times 2 minus 3, second power, minus 4. Plug in 3. I'll plug in 2 for x. 2 times 1 minus 4. 2 minus 3 is -1, but -1 times -1 is positive 1. We have 2 minus 4, which is -2. -2 and -2. 2 comma -2 right here, and 4 comma -2 here. Right. There's our graph. And trim. What say you? Positive, negative, or 0? How many times does it cross the x-axis? No. One's right here. One's right here. So therefore, two solutions. So therefore, discriminant is opposite again. It's positive. So why don't you go ahead and do a few, check with someone around you, get the hang of it, so we can go home and finish this up. Walk around and see if you got any questions.